Welcome, you're in the Math Zone, and I am your presenter, Patrick Gale. Today's objective is to find the gradient of a line. But before we can even find the gradient of a line, we need to know what a gradient is. So, what is a gradient? A gradient is simply a slope. A slope which is denoted by the letter m. It is seen as the change in y upon the change in x, which is also the rise upon the run, where the rise is your y-axis and your run is your x-axis. There will be a formula that you'll be introduced to find the gradient of a line, which is y2 minus y1 upon x2 minus x1, where these are coordinates. On our grid here, we can see a straight line with 2 points on that line. We normally write an equation of a line in the form y equals to mx plus c. As you can see here on your screen, y equals to 3 upon 2x plus 6. Now, if we can recall, m is our gradient. Therefore, 3 over 2 is our gradient for this particular line. But what if we were not given the equation of the line? Then it simply means that we would definitely need to find 2 points or locate 2 points on this line. And that is exactly what we are about to do in order to find the gradient. So we're going to start from point A and travel to point B. Point A is located at -6, -3. Let's recall that m is equal to the rise upon the run. And rise again is along our y-axis and run is along our x-axis. So starting from the point A, let's travel or rise along the y. Here we are traveling, and that is where we would stop. So if we were to count the number of units, then we would have gotten 6 units going up. So we rose by 6 units, which means that, again, we rise by 6 units there. So we have to insert that. So let's move across now along our x. So we are running across our x. How many units did we run across our x? That would have been 4. Which means that we will simply replace run with 4. 6 upon 4 there is a common factor between 6 and 4, which is 2. So we're going to be using 2 to divide into the 6 and into the 4. So 6 divided by 2, which would be 3, and 4 divided by 2, which would be 2. Which means that when reduced, we would get 3 upon 2. And if we can look clearly in our equation of our line, that is exactly what it was. 3 upon 2. Which means that we were correct. Now, the next method that we will be looking at, we can be given the same problem, but in a more structured format. We could be given the opportunity to find the gradient of a line which passes through points A, -6, -3, and B, -2, 3. These are points on the line. Using the formula in this case, m equals y2 minus y1 upon x2 minus x1. And we can recall that we normally start our coordinate or ordered pairs with our x followed by our y. So let's take, for instance, the coordinates for point A. Our x value there would have been -6, and our y value would have been -3. And for B, our x coordinate would have been -2, and our y coordinate would have been +3. So we will be taking the first letter there, which is y2, which is going to represent our first y value, in point A, which is -3, followed by our minus sign from our formula, then our second y value from the point B, which is +3. And we will be doing the same thing for x. So our first x value in A, there would clearly be -6, and our second x value after the minus would be -2. So if we were to calculate this, then m would equal to -6, because -3 minus 3, which would be -6, going more in the negative zone, and -6 minus -2 would be -4. Since -6, and when two negatives clash, becomes a positive, so the denominator reads -6 plus 2, which is also read as 2 minus 6. 2 minus 6 gives -4. And again, here the negatives will cancel out, leaving us with 6 upon 4, and when reduced, we will get 3 upon 2. So both methods do work in terms of getting our gradient of our line. So our gradient is 3 upon 2. I hope that you have been learning, and you can start applying as you go along.